Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is a Bafang Smart Battery Pack. So one of the lockdown units that everybody has been having to buy that nobody likes because now they can't use the unlocked controllers or any generic controller with this pack supposedly. But anyway, you can see that it is a BT F22.960.C. The BMS has got CAN bus on it that communicates to the controller. This one came to me dead because, well, it had a problem with the BMS, which I'll get to in a minute when I get over here. Anyway, the real problem was it had a blown fuse on it, and that's really all that was wrong with it. So why they put a surface mount fuse on it is stupid as can be to me. It's not how I would do it. So what I did was I replaced it with a 40 amp breaker, which comes out right here through the bottom. And it's got silicone on here right now, which is why there's tape in there so that doesn't leak out. But that way, yeah, the breaker pops, great. Just reset it and keep on going. No big deal. But with a fuse, yeah, you're as soon as the fuse pops, well, you're dead. That's it. You can't go anywhere. And getting this shell apart wasn't exactly easy. So this is not something you're going to fix on the side of the road or just go to the local auto parts store and buy a replacement fuse. Oh, no. This was a special fuse that is a really tiny little thing and just about impossible to find. I know I couldn't find it. So, yeah, Bafang basically screwed over their customers, in my opinion. This shell is fairly nicely made. As you can see right there, it says PC plus ABS. That means polycarbonate plus ABS. So it's a pretty nice piece of plastic. The polycarbonate makes the melting temperature much higher than ABS has, and it also adds some stiffness to it. So that's why it's a blend like this. And yeah, I can tell you it took more heat than I expected for ABS to be able to melt through it. Because that's what I did. I melted a spot through right here. Come on, camera, focus. There we go. To be able to add a breaker in here. So it's got silicone on it right now that's curing to hold it in place. But yeah, I replaced the fuse with a 40 amp breaker, and it was a 30 amp fuse. So it was a little bit more powerful, but it's not going to matter that much. Right behind it, you can't really see it so well because it's kind of half buried, but right there is the actual power connector, and you can see that right there. Anyway, that screws into the plastic, or rather it's got two M3 screws that screw through the plastic and clamp the connector to the plastic. So that was done pretty good. Definitely like seeing machine screws rather than screws going into plastic. This is your power connector, and those are 13 AUG wires going into an XT60. And this is JST possibly, I don't know. But yeah, that's your CAN bus wires. Down on this end here, this is charge, and that's an XT30. They buggered the wires right here. You can see how they're pinched. Yeah, I don't know why they did that. Also, these wires are nylon, and these ones down here are silicone. I don't know why they did that, but that's just cheapening things. You can also see this little part sticking up. So this is a thermistor, and it is connected up to the charging port. There was a little rubber boot over top of this thing. I just removed it just to see what was underneath it. But yeah, this little temperature sensor, it doesn't protect the pack from discharge over temperatures. No, this is purely for charging. This is so that the charger has some idea of the temperature of the pack when charging happens. And that's all it does. So yeah, kind of an odd design. I don't know why they did it that way, but hey, they did. Anyway, that's pretty much this. This whole bottom piece right here that mounts on here. So here is that. I did cut a little hole in it to go around that breaker right there. So when it pops out, it probably doesn't need this little window in it, but just in case if it does, then there's that little window, and hopefully the little breaker button doesn't catch in there, because that would kind of suck. It would basically mean you'd have to force past the thing. I don't think that's going to be a problem. I really think that this surface area here is enough, but yeah, just to make sure. Anyway, this is pot metal. It's not aluminum. I don't know what it is. Yeah, you can see inside there. The metal is grayish. It's not silver like aluminum. So, and it's all painted. You can't anodize pot metal. So, yeah. Anyway, I don't know whether you can see it in there, probably can't at all, but the breaker button is right in there, and it just totally clears that hole. So hopefully that won't ever be needed, but, you know, there we go. Alright, so let's slide this thing off and set it aside, and let's move on to the actual BMS. Yeah, so there's two spade lugs that will plug in here into that 40 amp breaker, and now you can reset the thing on the fly, and you don't have to worry about a blown fuse. Alright, so here's the actual pack, and the cells are all Samsung 21700 cells. You can just barely see on there what they are. So like right there, you can see it says INR2 something, and then SAMS. So Samsung 21700 cells of some kind. I can't tell you what model it is, because I can't see enough of the cell to see what that is on any of them. Anyway, yeah, it says on the outside of the battery pack that they are INR as well. So, yeah. Anyway, yeah, this is a 14S battery pack, and so obviously it's a 14S BMS. This BMS is overly complicated in my opinion, and then does give you enough functionality. Yeah, this right here is what looks to me to be an Atmel 428 CPU. They get used a lot on BMSs, amongst other things. You know, it's got enough horsepower to manage everything on here. Plus, it's got a few analog to digital converters, and it can do a lot of other stuff. CAN bus, things like that, which probably, like one of these chips right there is like the CAN bus transceiver. That's most likely what that is. This is a dedicated charge control chip. I can't see the part number well enough in there to say what it is. As you can see, everything is kind of all glossy because I did put conformal over it. Definitely like that. But whatever that little guy is, that's a dedicated lithium charge chip. And it's basically turning on and off all these MOSFETs right here, which then allows current to pass through all those resistors for balancing the cells. This is a jumper, essentially. So all 14 channels from here go into here, and with that unplugged, you basically disconnect balancing from all the cells. That's all that does. I saw that and pulled the thing up because I was thinking, okay, there's got to be something else underneath there. But nope, it's just a connector, and it's just a jumper, you know, input to output. That's it. Anyway, it was held down by this white silicone right here, which you can see. And I just, once I pulled it up, you know, I restuck it down again with black silicone. So that's what this is underneath there, just so it won't come out. Here's your charge port right there, an XT30. The power port is up underneath here, which is an XT60. And yeah, that's pretty much it. There is no temperature sensor here that I noticed. I guess I should scrutinize this board a little bit more to see if I can find a thermistor there, but I didn't see one just giving it a quick glance. There's not one stuck into the cells anywhere. You know, like I would have thought that like maybe down here on this end, you know, I'd see like a thermistor stuck down somewhere, but nope, there's not. So temperature monitoring in the pack, I don't know how that's being done. Or if it is even being done. Your guess is probably as good as mine is. Alright, so let's talk about this right here. So right across here, so this is battery plus, there was a fuse right there. A little surface mount fuse. As far as I can tell, it was a 30 amp fuse, and I'm replacing it with a 40 amp breaker. So a little bit more powerful, but it's probably going to be okay. Yeah, so I unsoldered that thing, and I looked and looked and looked, and I could not find that part number at all. So I finally gave up, and we're just guesstimating because, you know, the Bafang BMS or the Bafang motor controller is 30 amps, so 40 amps should be enough to be able to deal with that. So anyway, my assumption is that my 40 amp breaker that I've put in here, you know, is going to do the trick. To replace that. So essentially what I did was I took a couple of wires and you know, brought them down to spade lugs, which will then plug down to that breaker, and now you don't have an onboard fuse anymore. Instead you have a resettable breaker. Why Bafang did this, your guess is as good as mine. This is really stupid in my opinion. It basically guarantees that whoever blows that fuse on there has to go back to Bafang to get something replaced. for something stupid simple that they could have very easily have put external and used a breaker instead. Admittedly, that does cost a little bit more, but it also means that the user can just reset the breaker and be back in business again in 5 minutes. Whereas how they did it, yeah, that was fantastic. So over here, this is where CAN bus comes to this connector right there and then out to the controller. There is a connector right here, which I don't know what that does. Nothing was plugged into it. There is a connector for a ribbon cable right there that goes to the little button and the LEDs that are on the front cover so you can see quick charge status. There's a little switch right here, which I don't know what that does either. I did jumper that fuse once I knew that it was blown, and then the BMS all powered up, everything worked. I was able to charge the pack, which I'd never been able to do before. In fact, the cells were about 3.4 volts each, so yeah, it was pretty much at the bottom of its charge. And once I did jumper that, I tried flipping this little switch on and off, and nothing happened. So yeah, output voltage didn't turn off, charge didn't stop. So yeah, what that little switch does, I don't know, but here it is on the board. So right here you have a little onboard DC to DC converter. That's pretty common for BMSs. You know, that way you've got power for powering all this stuff. There's probably a linear regulator on here too. Just not really, haven't really looked at any of these parts, and I'm not going to. But yeah, little DC to DC. There is what appears to be probably a CAN bus isolation transformer right here, and that's probably making sure that CAN bus on here doesn't get zapped by CAN bus from the controller if you ever had a controller failure or something like that. So that's kind of cool, I guess. Would have just assumed that they didn't make this proprietary like they did, but they did. Anyway, yeah, this is all fixed now. Just waiting for the silicone to cure, and it's still a little bit soft. Still a little bit tacky, but not too much. I can touch it and it doesn't come up with my fingers anymore. So I'm just waiting for all this silicone to cure, and then I can put this pack back together again, plug these into my new breaker that I've added, and then this is a completely resettable pack. How Bafang should have done it originally. Anyway, that's pretty much everything there is to see about a Bafang battery pack. Yeah, weird that there's no temp sensor that I saw. Weird that they built it the way they did. Yeah, kind of a strange design. Yeah, I guess I should mention that too. So you can see all the silicone on here. So these two 12-AUG wires, they solder down to the two pads that the fuse was on. And this is called attention to detail. This way nothing can ever move. I've added silicone to all this stuff so that those wires are never going to be able to jostle or shift or anything like that, in which case they can't ever break loose off the solder pads that they're on. So yeah, I like seeing stuff like this, and obviously that's how I do it too. Same thing with that jumper over there. They did put silicone across it, and once I pulled that up, I added silicone right here to it as well once I put it back down again. So things like that are stuff that I would do, and when I see manufacturers doing that sort of thing, I always like that sort of thing, because this is something that's not going to come loose. It's not something that vibration is going to slowly cause a solder connection to break loose. It's going to stay put. So yeah, definitely like seeing things like this, and that's why I did that. They did put silicone on this CAN bus connector, which was cool. So when I plug it back in again, I will put a little bit of silicone on there as well, so the two of them can't come apart. So yeah, I had to cut the silicone to get that off. So yeah, again, that's kind of super cool. That was there. Definitely like attention to details like this. Well, that's pretty much everything there is to see here. Just thought I'd give you all a quick look of a Bafang battery pack.